Hi everybody, welcome to a very special edition of Absolute Science. Everyone yell, Absolute Science!
Absolute Science!
My name is Professor Toto, and I'm going to be your guide today for some really cool science experiments. Who's ready for some fun? I love to have fun, and I love to be silly when I'm doing science. But remember, whenever you're doing science, you also need to be safe. So today, I have brought a fireproof mat with me. That's because today, we are going to be doing experiments with electricity, experiments with chemicals, and experiments with magnets. But that's not why I need a fireproof mat. You see, everyone, today, for the grand finale, if everyone pays attention, I get to do explosions! Who loves explosions? I love explosions! But that's going to be for the grand finale. Today, we're going to start the show with an electrical experiment. Today, we are going to create a circuit. Everyone say, circuit. Nice job. Now, the word circuit comes from the word circle. So today, we're going to be creating a circuit of electricity. Now, a circuit is created by the steady flow of electrons. And in order to make a circuit, I'm going to need two special volunteers from the audience. That fellow right there, yes, with the glasses, and how about that girl right there in the pink t-shirt? Give them all a big round of applause. Sir, I'll have you come over on this side, and I'll have you come on this side. Now, for this very special show, 3 friends of mine are going to be helping. Later in the show, you just might see my friend Mary. And Mary, well, Mary is the mom of Kaylee. Kaylee is Iowa's youngest magician. And on this side of me is my buddy Rick. Rick is the founder, creator, and head honcho from Absolute Science. So whenever he's around, I get really nervous. I'm kidding, I'm kidding. It's time now to do our circuits. I'm going to hand one of these to each of you. Now I want you to hold it by the silver, just like this, in your right hand. Up on the bottom, just like that. That's perfect. Kaylee, I'm going to give you one too. Just like that, in your right hand. Hold it right by the silver. And I'm going to get one for myself. In just a moment, when I count to 3, Kaylee, Rick, and I are going to turn this to the side, and with our left hands, we're going to grab the other end right by the silver. When we do, we will create a circuit, a circle, and all of you will get to see what happens. Are you ready, Rick? Kaylee, are you ready? Audience, are you ready? Then let's count to 3. 1, 2, 3, go! Look at that! Lights and sound! We've created a circuit! And our circuit is Absolute Science!
Absolute Science!
Let's give Rick and Kaylee a big round of applause! Great job! You can go right back to your seats. Thank you so very much. Ladies and gentlemen, boys and girls, we have done an electrical experiment. Let's move on to some magnetic experiments. Are you ready for some magnets? I'm going to go right over here. I'm going to put these back down. We won't need these anymore during the show. It's time to get ready for our magnetic experiments. I have a steel ball and a neodymium earth magnet. They look very similar, don't they? But they're actually very, very different. We're going to start with the steel ball and a 1-inch in diameter copper pipe. I'm going to drop the steel ball from the top of the pipe all the way through to the red carpet on the floor. Your job is to count to see how many seconds it takes to drop from the top to the floor. Are you ready? I'm going to say 1, 2, 3, go. Then you count. 1, 2, 3, go. 1. 1? Well, that fell very quickly. So let's try the experiment again. But this time we're going to do it with the neodymium earth magnet. Everybody say neodymium.
Neodymium.
That's a really cool word. Once again, I'm going to say 1, 2, 3, go. Then you count to see how long it takes the neodymium magnet fall from the top to the bottom. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15? Boys and girls, which fell slower? The earth magnet or the steel ball? That's right, the neodymium earth magnet fell much slower. That's because even though the neodymium earth magnet is not attracted to the copper pipe, once I drop it through the pipe, an opposite force is created. That opposite force is called Lenz's law. Everyone say Lenz's law.
Lenz's law.
And Lenz's law makes the neodymium earth magnet fall slowly through the copper pipe. So let's repeat this experiment. But this time we're going to use a different copper pipe. We're going to use a copper pipe that's 1.5 inches in diameter. Do you think the neodymium earth magnet will fall faster or slower? Who says faster? Raise your hand. Who says slower? Raise your hand. Let's find out. Are you ready to count? Here we go. 1, 2, 3, 4, 5, 6, 7. 7? It did fall faster. Boys and girls, that's because the neodymium earth magnet inside the larger diameter copper pipe, well, it doesn't make as much opposite force, so it falls faster. So knowing that, what do we do with a 2-inch copper pipe? Do you think the neodymium earth magnet will fall faster or slower? I think you're right. Knowing what we already know, I think that the larger diameter will cause the neodymium earth magnet to fall faster because it can't create as much opposite force. Here we go. 1, 2, 3, 4, 5. You're right. That fell the quickest. But you know, I don't think I should be the only one who's having fun with Lenz's law. I think that we should play a magnetic game. Who's ready to play a magnetic game? I'm going to call up my friend Kaylee to play this magnetic game. Give her a big round of applause. Kaylee, come right over here on this side. Great job. Now, Kaylee, you and I are going to play a game together. I'm going to show you how we play, then it's going to be your turn. This game uses our neodymium earth magnet and 2 of our 1-inch in diameter copper pipes. The object of this game is to hold one pipe over the other, leaving a small gap in between. Then you drop the neodymium earth magnet into the top pipe. As it falls, you get ready to catch it in the bottom pipe without dropping it. Now, the game is not over when you do that, Kaylee. You see, when the ball drops from the top to the bottom, then you move the bottom to the top and the top to the bottom, and catch it again. Once you catch it again, you move the top to the bottom and the bottom to the top, and do it one more time. Do you think you can do that? I'm going to show you how we do it, then it's going to be your turn. This is what it looks like. Okay, I drop the neodymium magnet into the top. I wait for it to go. Oh, and I caught it. Then I'm going to do it again. Oh, one last time. And that is how we play this game. Now, Kaylee, are you ready? There we go. Kaylee, stand right over the red squares. Put one pipe over the top of the other, just like that. Now leave just a little bit of space just enough for the neodymium earth magnet to fall through. Right about there is perfect. Now remember, once it falls through, you move the bottom to the top and the top to the bottom. Ladies and gentlemen, are you ready? Kaylee, are you ready? Here we go. All right, leave a little bit of space, a little bit more space so everyone can see it drop through. Here it comes. There. Now move the bottom to the top and the top to the bottom. Just over there. Here it comes, Kaylee. Oh, one more time. This time let it drop all the way down to the floor. And everybody at home is going to give her a great big round of applause. Let's watch it drop to the floor. And there it is. Give Kaylee a big round of applause. Thank you so much, Kaylee. Well, ladies and gentlemen, boys and girls, we played a magnetic game, and it's absolute science. Super job. I'm going to put these down right over here. Now, we just played a magnetic game, and magnets are fun. But did you know that scientists use magnets every single day? Let me show you what I mean. I'm going to come all the way over here and show everyone my stir plate. Everyone say stir plate.
Stir plate.
Scientists use stir plate to mix chemicals and compounds. I'm going to do that for you right now. On top of my stir plate, I have a beaker full of water. Inside the base of the stir plate is a magnet. In order to stir what's inside the beaker, I need to add this. It's a magnetic capsule. Everybody say magnetic capsule.
Magnetic capsule.
I'm going to drop that in just like that. In just a moment, I'm going to turn on the stir plate. That little magnetic capsule will spin, stirring the contents of the beaker. So you can see it stir. I'm going to add a little bit of food coloring. I'm going to add 4 drops. Everyone help me count to 4. 1, 2, 3, 4. Watch the water. Here we go. Keep watching, everyone. It's creating what's called a vortex. It's like a miniature tornado. This is my stir plate, and it's absolute science. I'm going to turn that off because in just a little bit, I'm going to need this stir plate in my chemical experiment. But we're not done with magnets just yet. I have the biggest and the best magnetic experiment for you right now. Ladies and gentlemen, boys and girls, presenting the Mega Levitator. Everybody say, ooh. Mega Levitators are terribly expensive, and this one comes all the way from the Netherlands. Mega Levitators have one job, and one job only, to make something levitate. Let me show you how it works. Inside the base, I have an electromagnet. That means there's a magnet inside there that gets additional energy from electricity. I also have a magnetic disc. The magnetic disc and the electromagnet in the base are made to work exactly together. Now, have you ever taken 2 magnets and put them together, and instead of them attracting, they repel? That is the job of the base and the disc. If I balance this perfectly in the center, just like this, watch. Whoa! It's levitating! That's right! Now, have you ever heard of maglev trains? Why, they're in Japan and China. They're trains that levitate up above the tracks and are propelled forward by magnets. That same principle is being used right here. Now, my Mega Levitator is not strong enough to levitate an entire train. But since we all love the library so much, I decided that I would levitate some books. I brought 3 science books with me. Now I have to position each book exactly in the center. I don't want to disrupt the magnetic repulsion. If I do, the disc will come flying off, and that would make a loud crash. So I'm going to try to balance everything exactly in the center. I have one more book. Let's see if I can get it exactly centered, like oh, this is very scary. Let's see if I can get it perfectly centered. Ooh. We did it! Ladies and gentlemen, boys and girls, this is a Mega Levitator, and it's absolute science! Now, I'm going to take the books off. I don't want to accidentally knock them over during the show. There we go. Ladies and gentlemen, boys and girls, that concludes our magnetic experiments. But the show isn't over just yet. No, it's time to move on to chemical experiments. Who likes chemical experiments? I love chemical experiments. And in order to do this experiment, I need to put on some rubber gloves. On my table, I have a large beaker and a small beaker. We are going to start with the large beaker. I'm going to begin by filling it up to the 100 milliliter line with water. Everybody say, water. That's 100 milliliters. Then it goes on to the stir plate. I'm going to add a magnetic capsule. Everyone say, magnetic capsule. Now let's begin putting our test tubes into the large beaker. The first test tube contains starch. Everyone say starch.
Starch.
I'm going to put the starch in, and I'm going to turn on the stir plate. Just like that. We want to make sure that everything I put into the large beaker mixes thoroughly. In the next test tube, I have sodium acetate trihydrate. Everybody say sodium.
Sodium.
Acetate
Acetate.
trihydrate.
Dihydrate.
My next test tube contains large crystals. These crystals are sodium thiosulfate. Everyone say sodium
Sodium.
thiosulfate.
Thiosulfate.
Those go in just like that. I'm going to let that stir for just a couple of seconds before I add more water. I need to fill this to the 250 milliliter line. That's right about there. I'm going to put my thumb right there so I can see where the 250 milliliter line is. Right there. Let's put it back onto the stir plate and start mixing. It takes quite a while for those large crystals to dissolve. So while they're dissolving, I'm going to move on to the small beaker. Into the small beaker, I'm going to add hydrogen peroxide. Everyone say hydrogen peroxide.
Hydrogen peroxide.
There it is. Next comes glacial acetic acid. Everybody say, oh no!
Oh no.
Don't put that in there.
Don't put that in there.
I have to. That's part of the experiment. Glacial acetic acid. There we go. Now it's time to fill this beaker to the 250 milliliter line with water. There's the 250 milliliter line. Just like that. Let's see how this is dissolving. It's looking pretty good, so I can go back to the large beaker and add my final test tube. In this test tube, I have potassium iodide. Everyone say potassium iodide.
Iodine.
Let's put in the potassium iodide. Just like that. I'm going to let that keep mixing for a little bit longer. While that is mixing, I'm going to need a volunteer from the audience. Of course, I'm going to ask my friend Kaylee Rogers, Iowa's youngest magician, to join me. Come right up here, Kaylee. Here she comes. Come right over here, Kaylee. Thank you so much for helping. You've been a great help today. I am going to check to make sure this is all stirred up. We want to make sure that each and every crystal has fully dissolved. I'm going to turn that up just a little bit higher. We're going to let that dissolve for just a few more seconds, Kaylee. So while we're waiting, Kaylee is going to sing us a song. Oh, I'm kidding. We're just going to let that stir for just a few more minutes, Kaylee. Then I am going to let you hold the large beaker. You see, I'm going to pour the contents of the small into the large. Then you get to hold it, because it's going to explode in a huge fireball of doom. I'm kidding. It's not really going to do that. We are going to find out what is going to happen. Let's make sure this is completely dissolved. It looks pretty good. So I'm going to remove that magnetic capsule. Kaylee, are you ready? You hold this just like that. Here we go. Everybody watch the large beaker. Something remarkable is going to happen in just a few seconds. The suspense. Keep watching, Kaylee. Keep watching. Keep watching. Boys and girls at home, are you watching? It normally takes about 45 seconds to 1 minute for the chemical reaction to occur. Keep watching. Oh! Look at that! Wow! Did you know that was going to happen? That was amazing! We created a chemical reaction. This is Think Inc., and it's absolute science! Let's give Kaylee a big round of applause. Thank you, Kaylee. And now it's time for our next experiment. Well, so far today, we've done experiments using electricity, using magnets, and using chemicals. But now it's time for the grand finale. Who's ready for the grand finale? Me too. And for the grand finale today, I promised explosions. Who's ready for the explosions? They're going to happen right over here. On my table, I have calcium carbide. Everyone say calcium carbide. Calcium carbide is a chemical compound that, when mixed with water, creates acetylene gas. Everyone say acetylene gas. Acetylene gas is highly flammable. That means it catches on fire. Now, acetylene gas is used today in welding, but back in the 1800s, it was used in coal mining. Let me show you what I mean. Imagine it's 1890. And you are getting ready to go into the coal mine. In the bottom of your miner's lantern that you would wear on your helmet is a little bit of water. You then drop a couple of pieces of calcium carbide into the water, creating acetylene gas. That gas escapes through a little hole at the top of the lantern. You light that gas on fire, creating a little flame. The light from the flame is reflected off of the big silver dish, and then you can see inside the coal mine. Now, we're not going into a coal mine today, but we are going to do experiments using the calcium carbide. Let's get started. On the table, I have a tray full of ice. I'm going to put a little bit of calcium carbide into the ice. I'm going to let the acetylene gas escape from the ice. You might see a little bit of smoke coming up. That is the gas. Let's light it on fire. Are you ready? Here we go. Whoa! Look at that! Now you might think the ice is on fire, but it's not the ice. It's actually the acetylene gas that's being created when the ice melts and the water and the calcium carbide mix. Let's see if I can get a little bit more. Just like that. Ladies and gentlemen, that's calcium carbide. But we're not done yet. I promised you explosions. Who's ready for the explosions? The explosions are going to take place on our fireproof mat. Here I have a bottle with some water in it. I'll put that right about there. I'm also going to need a spark generator. That is how I am going to light the escaping acetylene gas. I'm going to need my calcium carbide. Let's get some calcium carbide. There we go. And I'm going to plug the top with a bandana. Now, if you have sensitive hearing, you might want to cover your ears at home. Are you ready? Here we go. I'm going to let that build for just a couple of seconds. 5, 4, 3, 2, 1. There we go. That was pretty cool. That was pretty loud. Should we do it again? Let's do it one more time. I have another bottle that's ready right here. Let me get that bottle. Let me get the calcium carbide. Here we go. Calcium carbide is ready. Boys and girls, are you ready for the grand finale? Our second bottle is ready. Our bandana is ready. Our calcium carbide is ready. Here we go. 5, 4, 3, 2, 1. And there it is, ladies and gentlemen, boys and girls. That was calcium carbide, and it's absolute science. Well, I hope you all had fun today, and I hope you learned a little something along the way. Remember, kids, if you love science as much as I do, there are lots of wonderful science books in your local library. Make sure you check them out. And when you go back to school, ask your teacher about science. Both of you will be glad you did. On behalf of everybody at Absolute Science, my name is Professor Toto. Thanks for watching the show today, and have a wonderful summer. See you soon.